Hello Year 10. Today we're going to be looking at the remainder and the factor theorem, but let's quickly recap the long division that we were doing last lesson. In this review question, we want to divide the polynomial, which is minus x cubed plus x squared minus 10x plus 4, and we're dividing that by x take away 4. Okay, to do our division, we do minus x cubed divided by x, which is negative x squared. Then we times the negative x squared with the x, which is negative x cubed, and then we times it with the negative 4 to make a plus 4x squared. Subtracting those columns, the x cubes will disappear. X take away 4x squared is negative 3x squared. Then we bring the minus 10x down and we divide again. Minus 3x squared divided by x is minus 3x. Timesing the 3x with each of my front terms, I get negative 3x squared. Minus 3 times 4 will be a plus 12x. Subtracting and the x squareds disappear. I have minus 10x minus 12 is negative 22x. Okay, then we bring our plus 4 down and divide again. Minus 22x divided by x is minus 22. Timesing that out, we get negative 22x. Minus 22 times minus 4 is plus 88. The 22x's will disappear. 4 take away 88 is negative 84. Then we want to write that in the form indicated in the question, the p of x equals form there. So for this question, that will be p of x equals x minus 4 times the quotient, which is minus x squared minus 3x minus 22, and then the remainder on the end, so minus 84. Okay, that's quite a long process to divide something like that, to put it into the form, to find the remainder of minus 84. There is a short method that will help us find the remainder, and that's what we're learning about today, which is the remainder theorem and the factor theorem. So first of all, the remainder theorem. If you want to divide a polynomial p of x by something like x minus a, where a would be a number, the remainder can be found by subbing p of a positive a into your polynomial. So that would mean if we were dividing by x minus 3, we would sub in p of 3. And whatever you get when you sub that in, that is your remainder. The factor theorem is a very special case. If you are subbing your x minus a, so you're subbing p of a into your polynomial and it equals 0, that means that this x minus a was a factor of your polynomial. A factor means that it divides exactly and there is no remainder. That's very, very useful if you're trying to factorize and solve things and even graph them later on. So there is an example here that if I had this polynomial p of x, if x minus 2 was a factor, then I would have a quotient here, but there's no remainder on the end. No remainder because it divided evenly out, or 0 remainder. So let's have a look. Question number 1. Find the remainder when the polynomial is divided by x minus 2. If I'm dividing by x minus 2, I want to sub in p of a positive 2. It's always the opposite symbol. And I sub that into my polynomial where the x's are. So that will be 2 cubed minus 5 times 2 squared minus 2 plus 4. And you calculate that, and we get negative 10. So that means the remainder is negative 10, and I didn't even have to do a long division. Question 2. Decide whether each of the following are factors of the polynomial. So if it's a factor, then when I sub it in, I should get 0 as my remainder. So let's try the first one. If it's x plus 2, I'm going to sub in p of minus 2. So into my polynomial, that will be 2 lots of minus 2 to the power of 4, plus 5 lots of minus 2 cubed, plus 2 lots of minus 2, plus 5. Unfortunately, that equals minus 7, which means that it is not a factor because there was a remainder. Let's try the other one. If I have x plus 1, I'm going to sub in p of minus 1, which will be 2 lots of negative 1 to the 4, plus 5 lots of negative 1 cubed, plus 2 lots of negative 1, plus 5. And guess what? That equals 0. So 0 means no remainder, and that means that x plus 1 is a factor. Question 3. Find the value of k such that x cubed plus 2x squared minus x plus k, when divided by x plus 2, has a remainder of 10. Now I'm dividing by x plus 2, which means that would be p of a negative 2. And if I was to sub negative 2 in, the question is telling me that the remainder should be 10. So given that amount of information, I can sub that into my polynomial. And this one here, even though it doesn't say it in the question, that is the p of x, the polynomial that we've been given in the question. And I'll be able to solve the equation to find the k. So p of x is going to be equal to 10 when I sub negative 2 into the polynomial. So that's negative 2 cubed plus 2 lots of negative 2 squared minus 2 plus k. So negative 2 cubed is negative 8. Negative 2 squared is 4 times 2 is 8. And minus 2 makes it plus 2, and then plus the k. So minus 8 plus 8, they will disappear. Oh, yes. And then I'm going to move the 2 across to the other side, and I will get k is equal to 8. Question 4. Use the factor theorem to determine all 3 linear factors of the polynomial. Now, this is an x cubed equation. It's a degree 3, which means that for a cubic equation, we would expect there to be 3 factors. And the question is telling me that there is 3 factors. The trouble is, I need to find them, and I don't even know any to start with. So, looking at the number on the end, that number tells us, or can tell us, what the possible factors of this polynomial will be. So given that we have an 8 there, some of my factors will need to be multiples of 8. So I can say for this that my possible factors that could come from the number 8 would be plus or minus 1, plus or minus 2, plus or minus 4, or plus or minus 8. They're all the things that you could divide 8 by. Now I want to do a little bit of guessing and checking to see if any of those work, if any of those give me factors. So you would start subbing in, and you'd start with p of 1. And p of 1 is going to be 1 cubed minus 5 times 1 squared plus 2 times 1 plus 8. But that equals 6. So it's not a factor. So you'd set this up in your calculator. We're going to go 1 cubed minus 5 times 1 squared plus 2 times 1 and then plus 8. So there's the 6. So it didn't work. If I keep that in my calculator, I can now easily check the other ones and hopefully not have to retype it every time. So if I try p of -1, I'm just going to do this on my calculator, and I'm going to go and change all those positive ones, into negative ones. So there, and there. And I press equals. Oh, and now it equals 0. So that means that that is going to give me one of my factors. Okay, let's keep trying. We could go to the next one, which is p of 2. Go back to the calculator and change all those negative ones into 2's. That also equals 0, so I've found another factor. When you sub in p of -2, I'm going to save us a bit of time here. Unfortunately, that one doesn't work. It's not my third one. You could keep trying and you could keep guessing until you've tried all of the factors there. And it does turn out that if you go to p of 4, which is the next one, it equals 0 again, which is your third factor. Now, guessing and checking can be a little bit of a pain. So if you don't like guessing, once you've found one or two of the factors, you could always do a long division and find the remaining factors that way. But I have found them all by guessing and checking here. So now I'm going to write down what my polynomial is in factored form. So my polynomial has a factor of -1, which means in a bracket that would be x plus 1. And a factor of a +2 would be x minus 2. And the factor of a +4 would be x minus 4. So that has now given me the factorized version of my polynomial. Okay, so now you can do exercise 10E.